Center of mass. Center of mass. Consider the motion of a body as shown in the figure. If the motion takes place along parallel lines or along parallel curves, the motion of the entire body can be represented by the motion of any particle of the body. The motion of the particle of the body, any particle of the body represents the motion of the entire body. Such a motion is called translatory motion. Such a motion is called translatory motion. Rotatory motion. If we observe the rotation of a fan, the particles of the blades of the fan rotate in circular orbits, different circular orbits. So, in this case, none of the particles represents the motion of the entire body. If the particles of a body rotate about an axis, the motion is called rotatory motion. So, in this case, in the case of a fan, the particles of the blades rotate about the rod through which the fan is suspended. So that is known as axis of rotation. So, if the particles of a body rotate about an axis, such a motion is called rotatory motion. Example, spinning ball, motion of a fan, wheel of a vehicle, etc. Necessity of center of mass. Necessity of center of mass. Let us suppose a club, a table tennis bat, is thrown up into the air at some angle. The motion of such a bat is shown in the figure. We notice that the handle rotates, or the entire bat or club rotates as it moves up. And if we carefully observe, a particle in the club moves in a parabolic path. Several particles of the body move in complicated paths, but only one particle moves along a parabolic path. So, we consider the entire mass of the body as though it is concentrated at this point, and we call this point as center of mass. We can describe the motion of the entire body with the motion of this particle. So, it is easy to describe the motion of the entire body with the motion of this particle. So, we imagine the entire mass is concentrated at this point, and we call this point as center of mass. Center of mass of different bodies. Let us take a rectangular plate. Draw the lines passing through the center and parallel to the length and parallel to the breadth. Then the point of intersection of these two lines gives the center of mass. See the rectangle, rose rectangle. The violet one, consider it is a box. Consider it as though it is a box. Draw the diagonals. Draw the diagonals, any two diagonals. The intersection of the diagonals gives the center of mass. So, whenever the bodies are regular in shape, we notice that the geometric center becomes the center of mass. Take for example, an equilateral triangle shaped body, a cardboard which is of the shape of equilateral triangle. If you draw the medians, they are same as altitudes, they meet at a point. The point of intersection of the medians will become the center of mass. In the case of a circular plate, the center of that circular plate becomes the center of mass. So, the center of mass of regular bodies is the geometric center of that body. In the previous case, we have seen several rigid bodies. In those bodies, the relative distances between the particles of the body do not change. They remain constant even if the entire body even if the entire body moves. Such bodies are known as rigid bodies. During the motion, if the relative distances between any two bodies, or between the particles of a body undergo change, if there is a change in the relative distances between the particles of a body during the motion of the entire body or system, such a system is called non-rigid system. Non-rigid system. Example, if we take sun, earth and moon, earth is going round the sun, or earth moon system is going round the sun. The distance between earth and sun is changing. The distance between moon and sun is continuously changing. Hence, to study such objects, we consider earth and moon to be a system. Earth and moon to be a system. Since the distances are not constant, so we consider it as a non-rigid system. A non-rigid system. Position of center of mass of non-rigid system. Position of center of mass of non-rigid system. Let us consider earth and moon as a system. We know that earth goes round the sun in elliptical orbit. Actually, it is not the center of the earth that moves in an elliptical orbit. A point near the center of the earth goes round the sun in an elliptical orbit. The position of this point is known as center of mass. We consider as though the entire mass of earth and moon is concentrated at this point. This point will be nearer to the center of earth and it will be towards the moon. By considering the mass of moon and earth and the distance between them, we can define this point. And this point is known as center of mass of earth-moon system. To describe the motion of earth around the sun, we consider this point. We consider the gravitational forces as though acting on this point. Position of center of mass of a ring. If you consider an object like a ring, the center of mass lies at its geometric center. So, the center of mass need not lie on the body. There need not be any mass at center of mass. So, sometimes the center of mass lies outside the body. Motion of center of mass. Suppose if we consider a rolling disc. A rolling disc. If we consider a particle on the rim, it moves in a curved path, which is a complicated path. A particle on the rim moves in a complicated path. If you consider the center of that disc, that center of the disc travels in a straight line. So, this is the geometric center of the disc, hence it is center of mass of the disc. Center of mass of the disc, it moves in a straight line. Hence, it is easy to describe the motion of this entire body if we consider the entire mass concentrated at this point, that is center of mass.